Friends, we have come in the fifth and last lecture of human factor modeling for operations. Now, and the last lecture is on quantification. Is the basic objective because finally we want to use this quantification in our risk modeling, or for any plant improvement, or for any root cause analysis, or for any precursor analysis in their relative measurement of relative importance. So quantification is the important thing, and we are talking about human factor. So now let us see what are the major element in this lecture. So ultimate objective is quantification, and why we need that, you know that because we are dealing in risk quantification of risk model, okay, and risk model is known because it is a scientifically developed model. So the data regarding human failure also should go with the accepted level of uncertainty. If suppose a data is having uncertainty beyond 5, generally we identify uncertainty as the 95% confidence divided by the median value when we talk about the log normal distribution. So, and then we talk about the data. So, the data is available, we will be able to do a good job, but it is a very tedious task to have data. So, what happens in such cases, we depend quite a bit on the expert opinion, and probably there is nothing wrong to go with the expert opinion and build our fuzzy logic model, and based on that the possibility of how a human will behave and try to characterize the human reliability model. Otherwise, if we have data, there is no issue. Individual human event failure probability is our objective. So here we will demonstrate the methodology. We will not like we are taking a procedural failure probability. The failure probability of procedures also is evaluated because when it was drafted, developed, approved for plant application, there could be some area wherein the operators, the kind of action they were mentioned, like it happened at times when we talk about the aviation accident and we say pilot who has done it something, a pilot error. But given the design condition and given the operation scenario, whether the pilot had sufficient time or sufficient input to his resources to take the corrective action is for somebody to think and decide. So, that is where the assignment of failure probability is based on the past data, but certain new situation has come. So, how far your model will be applicable there is a question. So, system failure, so once we have a procedural failure probability, we attach it to the individual human failure probability, and then we go to the system failure probability, and that is how we do through the CQB model. Let us see. Now, again we are discussing this again and again. Sense bases. Sense bases are like optics, auditory sense, smelling, speech, skin, body. These are all we have discussed at length. So let us come to the topic. And I think through the optics and some procedural element, we will demonstrate this procedure. And then at the end, in last 3 slides, I will give you the basic philosophy of how the failure probabilities are characterized. In CQB, there is a method which we again got inspired from the structural engineering method, that is stress strength. We will come to that also in last 2 slides at least. Okay. So, the again we are, I think, sort of revisiting what are the function of the frontal lobe, parietal lobe, temporal lobe, occipital lobe, primary. So, suppose if an error of smell or smell stimuli has happened, there are 2 elements. One is our sense organs, other one is what is happening at the brain level, and further that what is happening at the level of cognition level, that is analysis, and consciousness level, awareness level. So, these are the lineup that lead to a simple thing what we call mistake. You know, we have to characterize those things, and there are sense bases which are recorded by somatosensory cortex, and then central nervous system, very important part, which communicates with the control room, that is our brain, with the rest of the body. So, the efficiency of this should be 8 hours should be at the highest level when we are in the plant discharging our duties. Now, all these sense bases I have organized. Now, I am trying to model a problem and solve it, how to address the procedural component and other components. So, let us say I vision. We have a VI stands for vision, LI stands for listening. They are stimuli actually. So, and then SM stands for smelling. T or first word is consciousness, and conscious seeing, conscious listening, conscious smelling, taste, and sensation and thinking. So, conscious thinking is more important, is component of analysis, but it can enter any procedural steps actually. Okay. So, many steps, procedural step makes a task actually. So, that we will see in the next slide, and these are the stimuli connecting with the outside environment, and here these are action organs. They connect it to the outside organ where we are manipulating the changes what we have decided, tongue, hand, legs, genital organ, anal organ. So, for us what is important is mouth, that is tongue, hands and legs. We have taken these as a 3 stimuli. Okay. In the procedure I will be discussing, there is only one action item in the procedure. I will come to that. So, most part will remain in the sense basis and cognitive part. So, let us say I have a procedure which I have to characterize in terms of or quantify it. So, how I go about? Okay. So the procedure involved a very simple item. It is a task. I am calling it a generic task because this type of task form part of many procedures we develop, either complex or operating procedures. So, taking note of evolving scenario situation. First, you got aware about the situations. Then analyzing the second step is analyzing the situation. Define the objective and scope of the human action. Planning and collect the information, and then take physical corrective action. So, only one item, as I said, item number 5 is an action item. Obtain the feedback through audio visual further information, and then the results, success, failure, whatever. Now, suppose I will remain focused for step number 1, and through this step only I will explain the whole procedure. Others will repeat for the rest of the procedures. Other steps actually. So, our first step, I am assuming for while I model this problem, that first step is listening, vision and thought. These 3 are required. What you are seeing, okay. Take note of evolving scenario means it was listening was required, vision, some foul sound came. So, listening is one, then vision, I had extended my vision to the pipeline, to the wires, cables, and thought, what is this happening? So, you can say there are 3 elements in analyzing the step number 1, and total procedural elements were 7. So, for all the procedural elements we have used the stimulus, and mind you, I have not used the cognition, that is at brain level what is happening. Probably it might get covered through the thought item, but then as of now it is item number 1, and we are analyzing this only in further details. Okay. So, what happens? How we go to the step? Consider step 1, taking note of the evolving scenario. Then what are the stimuli there involved? So, step number 1, the stimulus are made up of CLI, L is capital, and this for successful success of the task, the listening, vision and thought. So this is a interaction, end gate. Interaction should happen, so that means all the three should happen, then only it will be a success. Three stimuli are required to perform a step number 1. Let us now develop into a mathematical model. So step number 1, there is a multiplication sign you are seeing. So that means this and this and this should work perfectly, then only I will be able to call the task as success. But you saw in our fault tree, we don't, fault tree means fault, that means failure probability we discuss. So that means for fault tree purpose, we call availability of this one of the sense bases. So that means are a complete step. So what will happen? Even if one fails, the task has failed. I did not see, I did not have vision, or I did not, so OR get. So it gets in failure domain, it translates into U1, unavailability is equal to CLI or CLV or CATH. So that means my unavailability formulation is summation, while success it was a multiplication, this is simple reliability mathematics actually, Now I have analyzed one step, but there were 7 steps. So if I do summation of J to M, there was J volume for Uj. Uj means okay. So all unavailability and this model will come and get plugged for all the steps, which is nothing but summation. Okay. So procedure has failed if any one of the item has failed. So here there will be a OR get. So summation will come, and for one unavailability it will be, so Uj, we have U1, U2, U3, U4, U5, U6, those availability. So this is the model when we analyze the stimuli, and we now know now what we are not having it in our hand. We are not having any probability of listening, vision, so here we can even go back to our plant record, how many times the person did not see and it became an error. How many times the incident happened because of vision, there was no clarity, either it was darkness, he could not see the vision, or it was he could not think about the thing very properly or cognitively. So those data will come. We have to create a time frame, 5 years, 7 years, get the data from the plant, conduct a expert opinion into you, what is the probability, how many incidents have happened because of not listening, not vision is not there or thought is there. I mean, there is a way to do it. So we have mathematical model, we have data or expert opinion, so we can overcome this problem of quantification here in the problem which we gave. Now we saw one thing, that when we were developing this stimuli, all the stimuli are not having equal weightage. Is first I should listen what is happening, then vision comes secondary, then tertiary, and then thought. So I will not say thought is the least important thing, but just for the explanation, let us say if I got vision, okay, consciousness level here 5, 4, 2, because I don't have any scientific model or data. So what I have done is I am trying to overcome that thing with an empirical table which gives if conscious level for a particular stimuli is high or low, very high. If it is very high, then we have this mark. 0.5 is the weightage factor. For the second, because all are not equal. So second one 0.35, third one 0.1, and this one. So so we have here and here 0.5, but this is 0.05. Weightage factor is 0.05. Okay. So sorry, here it is 0.035. Okay, it is secondary. Primary gets maximum marks and all, secondary, and then tertiary and all that. And for others also we can have this marking. We have not done it. So if we have this kind of things, we can bring in the importance of those stimuli also for that job. So how we do quantification? First of all, the idioms are weightage factor should of all the stimuli should be less than 1 or less than 1. It should not go more than 1 actually. And then task consciousness effectiveness. We have brought the element of consciousness also. So TCI is equal to summation of 1 to n stimuli and their weightage factor. Okay, consciousness level of ith stimuli and then weightage factor. For example, for the attributes given in table 1, suppose if it is 5 and weightage factor 0.5, 0.05, 0.35 for second, for third 0.1 and 0.05 for the last stimuli. So I think then we have got the grading of 4.9, but the required consciousness level was this one 5, 5, 5 and the weightage factor for them. So it was basically 5. Okay. So alertness coefficient can be calculated by consciousness this thing TCA by TR 4.9 divided by 5. So it is less than the expected consciousness. So the probability of particular procedure step or consciousness level is 0.98. So therefore consciousness coefficient for the task under consideration P for task under can be considered like this for a particular step. Okay. If we have better data, we can do that, but this is the way we can contribute. We have taken just one step actually. If we do for all the steps, we will be use this weightage factor because all the stimuli are not. We have to remember this, that all the stimuli are not equally important. The first stimuli, like I am passing through the area. So my sense of smell, that is most important. If I don't sense this other stimuli, they don't enter into picture. So weightage will be maximum for the initiating stimuli. This is how it conspires to. Now, when I want to explain the CQB model, as I was discussing, like it happens in structural engineering, stress and strength, they become the basis for evaluating the reliability of the structure. So you can see stress levels are normally lower than the strength. So our structures are safe, but when this diagram I have drawn just for a demonstration purpose, okay, and when they start overlapping, that means stress and strength start overlapping, then this region is called failure probability zone. We all know that if we have studied the structural reliability, and on the x-axis we have probability density function, and here we have stress oblique strength because unit is same for both. Now, same analogy has been extended to the human reliability modeling also. How it has been extended? We have control room parameter. Okay, we have a situational where stresses were supposed to be higher. Okay, but then our plant had this strength in terms of number of trips, parameter indication, mimic diagrams, in terms of supporting staff. These are called performance function. Okay, so performance shaping function. So we had this. So if strength was more, we will be able to cross, and this has happened when they were overlapping. But normally the plants are designed to have this strength distribution much farther compared to stress distribution. So that, and in nutshell, we want to ensure that there is no overlap. And suppose if one incident happened in the plant and it says there was an overlap, small incident happened, then we can look for redesign aspects of control room, and we should see what was the missing element. Does it say that the emergency demanded an intelligent operator support system so that his job would have become easier? That becomes a strength. So we should evolve continuously as the plant operation goes ahead, and that is where then what should be the parameter for creating a CQB model? So our model is based on stress strength ratio. I'm sorry, here stress strength ratio. So that means strength should be more than the stress, then it will be more than 1, and it should be in such a manner that these two curves, stress strength, they are not overlapping. So this is the, and then second assumption is in our model we have a reference. I told you we are creating a reference model. So, the reference failure probability that we get from the reference plant, it is basically from data collected from the plant or using the fault tree that we analyze during normal operation. So, normal operation stresses are very low or normal, but then during accident condition stresses increases. So, that gives our reference, that means the failure probability value is for reference condition is this much P0, to if I have to tell explicitly 10 to the minus 3, but for emergency condition it is going to be more. So, that means is it possible that the strength reduces and this during certain situation in time domain this start overlapping. That is another design perspective or design criteria or design metrics for the plant. Even for operating plant this has to be looked into it. That is why earlier concept of factor of safety, but of such a huge figure that these things they will never come. It was a very good thing, but the conservative now we are coming to the era of risk-informed, risk-based decisions. That means and additional conservatism should not load the plant in terms of not only reliability but safety also, because whether we have solved the problem of safety we are not sure. So, undue conservatism should be out, and that can come only when we have the plant data, insights, model and methods. Now, as I mentioned, AI and ML based online diagnostic system will reduce the operator strength. So, the strength component goes further up, okay. So, let us look at our mathematical model. Our CQB model where the non-performance probability, because we directly see this part, is a function of stress ratio, reference human probability, control room and training quality. Here, just to keep the things simple, we have used only 4 function over here. And then if you look at the model, this is a model, this is a non-performance probability which is a function of stress ratio. That means we will analyze stress in all the attributes or performance shaping function, not only in isolation regarding the operator, we will also evaluate in terms of strength of the plant, what all the provisions that they have and how those provisions will remain intact even for the emergency condition also. Okay. So, we have a stress strength formulation, and this is something new in CQB. Earlier it is the human factor reliability they were only focusing, and of course, this criteria of control room, level of advances and all those things were considered, but not the way we are considering as a stress strength model. Okay. Now, we have this model. Now, you see here, if this term is 1, the conscience, that means security related aspect is not there. So, in safety and not safety, safety risk and security risk, this model gets plugged over here through the term CS. So, probability of non-performance is a function of stress ratio is equal to 1 minus P0, that is P0 whatever we obtained from our reference record or in the probabilistic risk assessment record, and exponential SR by B, So, we have factor A and B, but I am talking about B only here because I am taking training quality, okay, keeping in view the scope of the lecture. Otherwise, A control thing also will enter here. Okay. So, the probability of non-performance which comes here, and the graph has been plotted here. You can see here the stress ratio. Now, you see how we have complemented this with the stress ratio and non-performance probability. So, as the stress ratio increases, the non-performance probability also increases. 0.001 is the reference failure probability for a given task, let us say. So, conscious coefficient a value of 1 only for risk modeling we have taken actually. So that's how this formulation, because we are talking about random failure, we are not talking about informed action to cause harm to the plant or security aspect. Now, procedural elements of evaluating a non-performance probability is identification of parameters that represent the postulated stress level, not the control room. That means move away from there, postulated stress level of the operator this is level actually of the operator, and then grouping of the above stress parameters and attaching the importance for each parameter through a weightage factor. We have done it in our previous step. Then repeat the step 1, 2 for stress strength actually, and evaluate the. Now, I was telling you expert opinion. There is a fuzzy logic approach. I will just touch upon this. In my chapter 7, you will find the full, or even open domain also you can find this methodology, where experts will express their opinion, what is the probability of this component failure or this or medical domain, this particular situation from 0 to 1. 0 means it will not happen, 1 means there is a full possibility. In between, I think so, very high, very low. So you have a complete spectrum available, and normally we use 4 to 5 attribute. I'll show you in the next slide. So stress ratio can be used to represent consciousness ratio as also cognitive stress ratio, and both can be represented through stress strength modeling and all. So, I will touch upon, this is a triangular function in fuzzy logic. So suppose expert says probability of this event is low, it could be 0 also, but it is saying low or high. So all they can be classified into low, medium and high. Okay, there is a trapezoidal function. It gives you one more class to develop. So trapezoidal means there will be 4 bases over here. So we can add. And fuzzy set A is represented as, suppose event A is there. Mu A x is a membership function. Okay, and A is a step. Okay, and function is x. So x belong to U, that is space that is available, and then where mu A represent the membership function. Membership function is look complicated here, but 0.1, 0.2, 0.2 for this element A. Okay, for expressing the opinion. So A is equal to I summation mu A x divided by xy. So it is some sort of a what is the probability or possibility. In fuzzy logic, it is called possibility for this particular event. And overview is, we have done modeling for sense basis, we have done overall performance, procedural performance, we have discussed the contribution of brain faculty not within the scope of say, because at brain level we have not done, because we require a very larger response to interact and to develop knowledge base, what brain faculties, what is the level, what are the symptoms they cause degradation and how it happens. Okay. So this is one thing. Often there is a interest in fuzzy logic. I have just touched upon. You can see in open domain also. If I have expert opinion and the expert whatever they will take, and it is basically to develop a quantitative modeling for the plant. So with this, I think our week 9 human factor modeling for in operations is complete. Thank you very much.